Uh, Good morning. Hello, hi. So today we will see about linear cryptanalysis. The topic name is okay. See, this cryptography is not comes under my thing, so I can explain in the point of view that you can get good marks in the exam. Not like I'm not going into much more detail and explaining the intuition and blah blah blah, those things you can read from the book. Okay, I'm just explaining whatever it is written, that's it, simple. Okay, so cryptanalysis means what? Breaking or analyzing the codes to uncover the hidden information. That is normal definition. So basically breaking the codes, that's a simple formula. Okay, so now today we will see about one symmetric cipher called like SPN. Okay, cryptanalysis means as a eavesdropper we will attack on it. Okay, we will attack we ourselves only, we will treat ourselves once the protocol is ready. I mean, once this algorithm is ready, making of plain text to cipher text, now as ourselves only we will become like a eavesdropper and we will attack on our algorithm because we want to know the loopholes of the algorithm. So if we do cryptanalysis ourselves, then we can learn the wherever our lagging it is, and then we can try improve upon, no, so that at the end of the day we will make a perfect algorithm. Okay, that's the intention. So in symmetric ciphers we have seen that normally in the real world we will use generally AES or DS. Okay, since this breaking of ASDCS is a very difficult, so for that purpose, like we will take one normal SPN. Okay, SPN is a symmetric cipher algorithm. Okay, symmetric cipher algorithm is simple. Input is normal plain text, output will be some cipher text. Okay, that's the funda of the algorithm, means input and output of the algorithm. Okay, for this we will use, see, the inputs will be, x will be plain text, phi s means s box function. What? S box function. I will tell s box function you have learned about, or else I will tell again. Okay, don't worry. This is p box, permutation box, and these are like our round keys, n plus 1. Remember, here are n plus 1 round keys. Okay, remember in this one, in this thing, if they are n plus 1 round keys, then there n rounds. For n rounds there will be n plus 1 round keys. This has to, you have to remember. Okay, nice. So first here, see, don't worry about this, these are bacha only, these are like, don't worry about this notation, just try to understand this normal thing. Okay, what it is saying. Initially we will take our plain text. Okay, happy, take our plain text. After that, what you have to do, you have to do, see bro, you have learned last semester what, for from master key means there will be one key. Okay, from that key we will produce some n plus 1 round keys. Okay, okay, from the master key we will produce some n plus 1 few more keys, so that those things are called as round keys, and the head from where it has been formed n plus 1 is called master key. Okay, that is kr. Okay, okay, that is how this produced n plus 1 round keys are produced. Okay, that is what I explained here. Now see, for the first time, means take first round key k1, when r equals to 1, take k1, w will be w0, just XOR both things, name it as u0. Okay, after that here, here for I is equals to 1 to m. Okay, I is equal to 1 to m. Here see x will be like a very big thing. Okay, now what we are doing, x taking again with the round key kr, k0, k1. So same again same length. Then we are doing zod produces same length, as we all know. This is nothing but u1. Okay, now what we are doing means this big one is there, no? We are dividing into bacha things. We are dividing into m blocks. Divide such a way that at the end of the day we are having m blocks. Okay, if size is like a total p bits, then after m blocks, each block contains how many bits? P by m bits. Okay, it doesn't matter, just normal tell. So main intention is that m blocks. Now for each block, take this one. Okay, take u1 and apply s function, produce result. That is what we are written. But thing, don't worry about this notation, don't fear about notation. So we are applying this function normally, you know, in normal kids, how we will write function means like f of x equals x square plus instead of f they are taking like fancy term pi s, this representation, don't worry. Okay, here also they are, here subscript they are using ur is like a very big thing. Okay, to indicate the block number we are writing subscript, I mean what you call subscript only. Okay, like this means first block, second block, third block, and so on m blocks. Okay, after applying s function on all these blocks, what will you get? Apply s function. I will tell about what is s function. Okay, don't worry. We will get to like this. Okay, now we are naming this thing as a wr. Okay, happy? So wr here, the first iteration, it will become w1. Okay, from you basically it's nothing but saying is like you given as for the s box function input and it produces w dash bus. This is what this loop means. Okay, like that like that create all these things. Okay, u2, what is u2? u2 is nothing but again from the previous one we are taking help. Okay, u2 is nothing but w1, I mean w dash or what is k2. K2 is our round key k2 and w dash means previous one. So from this one form u2 and again phi s phi 2. At the end of the day we will all produce like this wn. Okay, it goes to n minus 1, so we'll produce n minus 1. Okay, finally we will at last we will take about this one and take nth ground key and we will XOR it and we will produce mu n. Okay, after this is to get this one we are doing this much activity. Okay, this much things. After that normally we will going for each loop again, iterate through each block. Okay, slowly you understand. Again iterating for this each block means un to the phi of s. What will it become? It will become, I mean sorry, not un, un only. Un will become vn. Okay, again whatever the vn comes, no, that vn is or with kn plus 1, n plus 1th round key to get a y. So this is what ciphertext finally. This is normally algorithm. Okay, process working. This bacha thing, you understand, no? Now let's see about s box. So here in our case, in our example, we are taking some example. So remember that n is nothing but number of rounds. If number of rounds n will be n, then there will be n plus 1 round keys. Okay, see here we are taking x box input means this one u dash. We are taking like u dash as a what, sorry, we are taking each block will be containing 4 bits. Okay, this is what we are assuming. So 4 bits will be given to X box, it will produce 4 bits output. This is what the here it is written. Okay. M means I told no, there will be 4 blocks. Okay, each block containing, they are saying that length will be 4. Okay. Okay. So for 4 bits, tell me what will be the possibilities. 4 bits will be 0 0 0 0 0 1 0 0 1 0 0 0 1 1 and so on, 11111. So this is called binary. Same right in hexadecimal, what will happen, tell me? 0 1 2 3 4 5 6 7 8 9, not 10, it will be called as A. Okay, till F means 15 in the decimal, you can think. Okay, this is what a hexadecimal. So we are giving input, you have to think like this. Whenever we pass through the S box function, you will get the output of 4 bit. Okay, when I pass 0 as a hexadecimal function, 0 to pi of s, it become what will output E, means 0 means nothing but 0 0 0 in the binary format. E means 14. Okay, 7 to the 14, like this. Okay, happy? So this is what about S box table. Okay, again here P box. See, what permutation box is nothing but the name itself saying that permutation means if you take a location 1, see I will tell about first normally permutation box and how what this here it's mean. Okay, normal permutation box means, see, if I am having permutation box is like this. Okay, just 4 only. So let's say indices starts from 1 2 3 4. Okay, so this is called outside indices. Okay, just think like it is in our brain. So now what we are meant to say means, let's say we are having like all alphabets A B C D E F G which are having positions 1 2 3 4 5. Here what they mean to say means, take first one. Okay, now replace this by 10th position alphabet, and whenever take second position, replace this by 5th one, and whenever see about 3 at the position 3, replace it by 2 second position value. Like that you have to think of, that is called P box. So similarly they are saying that whenever you given this again P box is taking all these things are like in the decimal format only, decimal number, bacha normal decimal number. Okay, so for the first one you have to replace it by first position only. So at second one you have to replace it by 5th position, like that. And this is called permutation box. Now we will see about one example. Okay, chalo. So let's say this is our master key. Okay, this is called master key. From this master key, let's say we have generated this 5 keys. 5 keys means we have applied 4 rounds. Okay, we have done 4 rounds of some algorithm and we have got these 4 round keys. Okay, this is thing you have to remember. After this one you will proceed, we will proceed this as usual. So see, don't see about this thing, just go by normal whatever I told. Okay, we will take first this one. Okay, now between these two things we will jar it. Once we will jar it, we will get this one. After getting this U, now push U to the what, where we have to push S box. After getting U, what you have to do, tell me, please tell me. After getting U, divide into chunks. Okay, this is called blocks. Divide into the 4 blocks, each block is containing 4 bit. Okay, and whatever this block given as it is as a input to the S box. So for 0001 when I given to the input, what is this hexadecimal format? Value 1. This hexadecimal format will be how much? 3 into 4, 12. Okay, how much? 2, 3. So 12 can be written as C. Okay, for 1 what is the value, bro? 4. For C what is the value? 5. For the 2 what is the value? D. For 3 what is the value? 1. So D can be written as F means 15, E means 14, D means 13. So 13 means 8 plus 4 plus 1. So 1101. Okay, like the D value. So 5 means 0101 is normal 001. This means 100. Okay, so this is what we have written. This is what nothing but V. Okay, Samjha, you got my point? See, as it is, as it is. Like this you proceed. Okay, just for a beginning only I am telling, taking very late, but once you understand, just do yourself only for practice purpose. After that, after getting this one, now what we have to do means, just actually see, bro, I have forgotten. Arey man, we have to update this now. This is permutation box. After getting this, sorry for my bad mistake. Bad mistake. Bad mistake. Okay, after we are dividing into the 4 blocks, we have passed through S box and we have gotten the information. Okay, we gotten this what you got, V. I again pass through this permutation box. You got W, UVW, like this. Okay, arey man, big mistake rah. Okay, no problem. So again you have, once you got these values, pass this to the permutation function. So convert this value to the 1, 2, 4. So value will 4. 5 of 4 means 13. 13 means how can you written? Sorry man. See, after V value getting like this, we should not give completely this to that. Okay, you have to think like this. 1, 2, 3, 4. Five, 6, 7, 8, 9, 10. Bro, so I told now how to check permutation P box. So this is our matter content, like you can think like A, B, C, D, F. Now outside you have to write like this. Outside you have to write like this numbers. Okay, now you have to see, for the first alphabet 1 is replaced by 1 position only. Okay, 0 is replaced by 0. Happy. So 2, for 2 what is the value? 5. So what is that value? 5. So 0 will be written here, 0. Okay, again 3 means 9th position, 9th means position 1, that's why you are written like this here. Again 4th position is 13 means this value is written by here. Again 5th position means second position 1 is written. 6th position means as it is copied. 7th position means 10th position 1 is written here. Like that you have to written. Okay, after forming this one, now again you will solve with these 2 things, produce this one, apply S box, you will get this one, again apply permutation box, you will get this, and do this nonsense thing up to till 5, up to Y, and finally produce Y. Okay, generate Y. what I meant to say. Okay, that's it. Happy. So this is all about the working procedure. Okay, whatever we have written here, this we are keeping a very good looking picture. Yes, so in this picture, in our example, since they are given like we have to take 4 blocks, each block is having length 4 bits, and we are having n rounds will be 4, so there will be 5 round keys. This is our no, that's why we have divided our, let's say plain text is 16, so we have divided into 4 blocks as it is given. So that's why 1 2 3 4 blocks. Block number 1, block number 2, block number 3, Sairam, block number 4. After that we have passed XOR with the round key, and we have produced U1, and then we pass through the S box, and we have produced the results like this. Again we pass through the permutation box, so this is what they are indicating. Okay, see, this is the second bit. Second bit is replaced by where? Fifth bit. I mean, see, the understanding thing is here like this. Okay, see, this is very normal common sense if you apply here. Okay, see, our main intention is after producing this v dash. Okay, after producing v dash, now you can apply the permutation box. Permutation box says that if you are having second bit, okay, second bit has to go where? 5th position. So okay, we are sending this second bit to the where? 5th position. 1 2 3 4 5 here, 6 7 8 9 10 11 12 13 14 15 16. Okay, similarly third position is went to the 9th position. Like this. Okay, you understand how to draw these lines? Instead of indicating the permutation box here, we are indicating through the lines, so that this is understandable. Means you can think like transmit 2 to 5th position, transmit 3 to 9th position, like this. Finally we will form the W dash. Again, once the W dash is formed, you know what to do. You round key with I mean XOR with round key. Okay, sorry, round key with array man. So like that we have to do continuously. Okay, blah 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 blah, finally achieve y. That's very simple. So this is all about linear cryptanalysis. Okay, very bacha thing, no? Easy. So now we will go to next concept. So for that concept we require some little bit definitions, mathematical definition, then we will finally learn the concept. Okay, now let's see about some mathematical concept. So okay, today, so the first topic is SPN now, bro. Next topic is linear cryptanalysis. So linear cryptanalysis means just read this definition once. Okay, find a probabilistic linear relationship between the subset of plain text bits and subset of state bits immediately preceding the substitution performed in the last round. Okay, what they mean to say, simply find this relationship between this and before substitution, means this for the last round. Okay, I don't know, n equals to 4 means 4th round is our last round. So this is what they want to mean to say, finding some linear relationship. This, so now we will see about some mathematical background to know about linear cryptanalysis. So some small definitions, common sense definitions we'll see. Okay, bacha definitions only. Okay, so let's go. I will make it up ready and I will start. So until then, watch this one. He left everything. He's going to share that. Very nice. Okay, so let's come on. So the mathematical background is normal but common sense things only. Okay, we will discuss in just we will complete this thing 10 minutes. Okay. So let x1 x3 be there some random variables. Okay, so let's say there are some variables are there. Okay, those are independent random variables. Some variables are, see, random variables are nothing but for a variable we are assigning some function, some value. That's just think like this. Okay, simply don't think much. If you really want, you go and time waste it. So x1 x2 so independent random variables taking values from the set 0 1 means each this can be either will be 0 or 1. This can be 0 or 1, not both at a time. It will be like at one particular instance the value will be 0 or 1. Okay, this is what it means. Okay, let p1 p3 be all the real numbers such that their value will be always 0 to 1. Okay, pi value belongs to capital 0 to 1, I mean close bracket 0 to 1 interval. Okay, now we are saying that this is like our definition, bro. See, first we will define some things. Define means whenever we defining, you should not say ask any questions, just blindly accept it and follow it. Okay, from this assumption you can think like, it's not like assumption, or you can think like anything. Okay, whatever you want to think, it's like we have to accept it, and from that accept it we will draw the conclusions step by step. So in that conclusion, if you don't understand anything, then you can have a right to ask. Okay, this is what we will follow in normal any mathematical logic or whatever. Okay, let's come on. So we are defining the probability of random variable, ith random variable equals to 0 as pi. Okay, then what is the probability of xi equals to 1? Since there are two events only, 0 or 1, I mean there are two chances, then it will be like complement 1 minus total probability 1 minus pi. Okay, see, summation of all events equals to, means all probabilities equals to 1. so here possibility is 0 or 1 equals to 1. so this way pi, this value will become, let's say, x 1 minus pi. This is what they have written. Okay, fine. So see what this notation according to our mathematics means, probability that let's say this name it as e1, this is name it as e2. so probability that e1 intersection e2. In mathematics we know that if e1 e2 are independent events, then we can write e1 into probability of e2. That's what they have written, nothing else. Okay, normal bacha mathematical formula only they have written in different format. Instead of intersection they are using comma. Okay, now tell me, whenever this is given, so probability that xi equals to 1 and xj equals to 0. so think like a e1 event, this has a e2 event. so probability of e1 comma e2 means e1 intersection e2, that is probability of e1 into probability of e2. probability of e1 means probability that x1 equals to 1 into probability of xj equals to 0. so probability of x1 equals to I means 1 minus pi. Okay, this is how we define it here into pj. Simple things. Okay, now after that, now we will consider one random variable. See, bro, don't die. Okay, don't die. By looking this, don't die. This is normal bacha alphabet variable only. Okay, you can, if you don't like to see this, just think like some y value, or if your name is t, then think like some ti. Okay, some tk, some like that thing. Normal variable only. so that variable, to get this variable is nothing but we have to taking XOR of these two things. Okay, this is what they mean to say. See, again I have discuss in the last my previous videos about XOR. I mean, in between I have discussed very detailedly, or not else you can listen here also again. So see, bro, XOR is nothing but see, mod 2. the simplest thing. See, if anyone is given, bro, x y x or y, if anyone asks like this 1 0 1 1 1, so the simplest thing to answer is don't remember like anything. Means bro 1 0 means if one value 1 then it 1 when both are same then the value will become 0. Don't remember like this, bro. Okay, if you remember like this then you can be able to do for two variables. For next time, let's say when I have given 0 0 1 1 0 1 1 1, so for this things to do in a very fast way with accurately, you may not do by remembering like this logic. So XOR is nothing but it's a mathematical operation of modulo 2, addition of modulo 2. So XOR is nothing but addition only, but take modulo 2. Okay, 1 plus 0 how much, bro? 1. Normal addition, bacha addition. 0 plus 0 how much, bro? 1. 0 plus 1 1. 1 plus 1 2. So take modulo 2. So 1 mod 2 1, modulo 2 0 1, 2 mod 2 0, like this. So remember, when if I given x y z k, when I ask all XOR of these things given 1 0 1 1, so the answer should be what? Bacha, nothing, just add all these things. Okay, when you add all these things, what is value? 3. 3 mod 2 value 1, so answer is 1. Like this, very simple you have to tell. Don't take means don't fear anything, this bacha thing only. So probability that, see, now we want to find this value. So now this is not a formula, this is now this we will derive from our all this assumption, this only from this definition. So we have to find this value. So how to find it? See, xi xj can take value either 0 or 1, can take 0 or 1. So together how many values? 2 into 2 4. So write like this 0 0 0 1. Means if you know my fundamental principle of counting, if one work is done in m ways, another work done by in n ways, then both can be done m into n ways. Like that here also. Okay, something simple thing, easy thing. Okay, now xi is or x2 means just addition 0 1 1 0. So see, now we are asking the probability that this value will become 0. So probability is nothing but favorable outcomes by total number of outcomes. Favorable how much, bro? 1 2 2 by how many total? 4. 1 by 2, that is 0.5. like that. Okay, you have to think like that. Okay, but here see, what I mean to say means just neglect it, remove whatever I told here. So I am talking about here possibilities. What will the in what cases it will become 0? Tell me. In these two cases, right? 0 will happen. This case and this case, means I can write similar statement as probability that xi equals 0 comma xj equals to 0 plus, okay, plus probability of xi equals to 1 yi equals to 1, I mean xj equals to 1. So again, to get xi equals, again this formula you know is nothing but pi, means comma is nothing but intersection. For independent events the formula is just multiplication of individual. So pi into pj, so 1 minus pi into 1 minus, like this, some nonsense things you have to do. Okay, happy. Now let me define the bias value. Okay, bias, the definition itself is state that bias of a random variable, xi is random variable, bias of random variable is nothing but probability that random variable exactly equals to 0. See, in our case the starting assumption only that random variable can take either two values only, it can have 0 or 1, it don't have 0.5 or 0.6 or 0.7 or 1 lakh or 2 lakh, it is having just two values, 0 or 1. So bias is defined as this, you have to remember very importantly, bias is defined as probability that xi equals 0 minus 1 by 2. Okay, minus 1 by 2. This is how it is defined. That's it. Okay. One more thing just to discuss like this thing. See, probability of, if you take xi, we are having 2. Sum of probability is equals to 1, right? For same random variable, not different random variable. So here equals to 1, sorry. So here you can think like same, this formula can be written as probability that xi equals to I minus of. Can we write like this? Answer is no, we cannot write. Okay, we can write like this: 1 by 2 minus probability of xi equals to 1 from this one. Okay, anyhow leave it. Okay, so you have to remember like this: epsilon I means what? Probability that xi random variable equals 0 minus of. This is what you have to remember. So once probability is pi belongs to 0 to 1, then pi minus 1 by 2 will belongs to, tell me, minus 1 by 2 to 1 minus 1 by 2. How much? 1 by 2. This is what they have written. So similarly they have rewrite the functions again. What? Probability that xi equals to 0 equals to 1 by 2 plus ei epsilon I. Because probability of xi equals 0, how much? Pi. Pi is nothing but probability. Pi means probability xi equals 0. Probability of xi equals 0 can be written as 1 by 2 plus epsilon I. So this is what they have written. Very simple things now. Okay, so next we will see about one theorem. Okay, piling up lemma. Okay, piling up of lemma. Okay, so piling up of lemma means, okay, so see bro, epsilon ei1. If I write this, what you have to strike in your mind, it is, you have to call this as what? Bias of a random variable RV, random variable xi, xi1. Okay, xi1, that is equals to probability of pi1 minus 1 by 2. That is equals to probability that random variable xi1 equals to 0 minus 1. This you have to remember. Now what we are saying means the probability of epsilon I1 comma epsilon I2 is nothing but bias of probability of, whenever comma is there, here there will be 0. Okay, this is what they mean to say. Okay, this is what's in simpler format I am saying. Means if you read this thing, then you will die up. Means if you are like seeing for the first time, then you will may tensed out and you may lose the interest. But this is like normal bacha thing, you have to understand this thing. Okay, so let denote that there will be epsilon even I comma up to k be denoted and bias of random variable, all these things. Then they are saying that there is the relationship between all these things at a times, and epsilon means this can be written as epsilon I1, epsilon I2, and then epsilon ik. Okay, into 2 power k minus. This is what they are saying. So now we will prove. So we will do by proof by induction. Okay, here proof by induction you have to read yourself if you want on internet. Okay, so here what does we will do in proof by induction. So see, just for because of you I can proceed directly proof by induction, but you will become tensed again. So I don't want to take any fear. We will proceed it. Okay, from the mathematical perspective. So let's say, see, just read yourself only, or else just listen my thing. Okay, so here we will prove by normal regular induction only, not by strong induction. Okay, in our case, let's see about these two things. Okay, so initially see, if given one statement bro, okay, we have to tell that for base case, means for every statement there will be one base case. No, so here the base case will be like true for a n naught value. So we will assume that it is true for n naught value. Okay, normally we will prove that we'll prove that base case is true. Okay, after proving this base case, we will hypothesis means, okay, we are assuming, or we are thinking, oh, okay, maybe this is true for k. Let's assume that hypothesis, our strong belief. Now by this information, if we can conclude that it is true for k plus 1 also, then you can say that your hypothesis is correct. Hence it is proved. Happy. This is what proof by induction template. Okay, for strong induction, see here base case we are considering only one case, that is called base case. Here we are saying that here also we are considering base case only. Okay, but in the induction hypothesis, here we are considering it is only one value, but here we are saying that instead of only one value, we are considering one range. Means the range is going from the base case to the some value k. We are saying that this is for this whole range of values, means it is true for our assumption is true. Assume is true means that we are saying that the statement is true for all n naught plus 1, n naught plus 2, and so on k. Finally, inductive step is show that the statement is true for n equals to k plus 1. Okay, this is what they have written. So if these steps are completed and statement holds by mathematical function, we can conclude that statement is true. This is all about proof by induction, bro. Okay, so in our case, what is our base case? Base case can be, you can think of a k value is greater than or equals to 1. Okay, you can think like this, basic funda. Or you can say that instead of 1, let's say if you consider greater than or equals to 1, take k equals to 1. Tell me, it is nothing but only one variable, epsilon value 1, xi 1, and what will you get? You will get nothing. Okay, so therefore you will consider this statement is true for k greater than or equals to, then some maza will come. Okay, I mean, then it is whatever we have discussed, it is true. Okay, now we are following the, tell me, proof by induction by regular induction. Okay, regular induction proof. So this is our form. So what is the base case? Base case is clearly evident. What equals to is the base case. Let's say it is true for means we have to show that this is, we will get, what we mean to say means RTP, required to prove that epsilon I1 comma I2 equals to 2 power 2 minus 1 into epsilon I1 into epsilon I2, that is equals to epsilon I1 into epsilon I2. This is what we have to show. So how to show means just consider LHS. So consider LHS means this epsilon I1 comma I2. So this can be written as how? Probability that xi bar xj bar equals to 0 minus 1 by 2. I mean I1 I2. Again this can be written as how? Tell me, xi1 equals to 0 comma xi2 equals to 1 plus probability that xi1 equals to 1 comma xi2 equals to 0 minus 1 by 2. Again this can be written as how? Tell me, half into pi1 into 1 minus pi2 plus, why we are writing 1 by 2, bro? We shouldn't write. Okay, here tell me p1 minus pi1 into pi2. Okay, minus 1. See again pi1, what is pi1, bro? pi1 means epsilon I1 plus 1 by 2. We have seen here just now before only. If you forgot, then it is your mistake. I mean sorry, p minus 1 by 2. Whatever, bro, this is what I mean to say. Okay, Okay na? Nice. So how can you write this then? Tell me, like pi1 means epsilon i1 plus 1 by 2. pi2 means whenever I do p minus i1 will become how much? 1 minus 1 by 2 plus epsilon i1 and 1 by 2 minus epsilon i2, bro. Okay, do this thing. I'm doing slowly. I cannot talk so much, and my voice has gone. That's the major problem. Okay, 1 by 4, this one is cancelled. Okay, so finally what will it become? Tell me. Minus 2 into epsilon i1 epsilon i2. So this is what we want to get now, right? See, 1 minus is extra k. Now I am figuring out why it came. Actually, bro, this is 0, bro. Very bad mistake. Hey, you are a dog actually, Shivakishan. Stupid. Okay, so finally what will happen, bro? Okay, this is what we will got, means this is what we have to prove now. Okay, 2 minus 1, it's 2. Okay, sorry. Okay, happy. And now hence base case is proved. Now we will assume that let the statement is true for some k, where k greater than 1, of course, greater than 2. So if you assume the statement is k, so we are declaring that epsilon I1, I2 and so on, ik is nothing but 2 power k minus 1 phi into epsilon epsilon j, where j equals to ij bro, j equals to 1 to k. This is true. Okay, we are accepting this. Okay, acha, it is true. Okay, fine. Okay, nice. So now what we are doing? Tell me now what we have to do. Now we have to prove that this is true for k plus 1 statement also. So how to prove it? So to prove that, we have to include one more variable. So true means what you are accepting here? Tell me. Probability that xi1 zar, xi2 zar and so on, xik zar equals to 0 minus 1 by 2 equals to 2 power k minus 1 phi epsilon ij, where j equals to 1 to b. This is what we are accepting now. Okay, now let's do it for, now consider this case. Consider epsilon I1, I2 and so on, ik plus 1 also. So this can be treated as epsilon tell me xi1, I2 and xik zar ik plus 1 minus 1 by 2. Okay, now what I am doing means I am treating whole this thing as a some variable. What? Some variable. Let's say name it as some x. So x, capital X jar with x ik plus 1 minus 1 by 2. Okay, can I write like this? This probability same thing, can I write like this? Epsilon can I write whole this thing as epsilon? Yes or no? Yes. Okay, I can happily write like this. But we know this, what is this formula? For two variable, what is the formula, bro? Array man, we are saying this value is whole true for k greater than or equals to 2, right? For two variable, what is the formula? We have seen that this can be written as means epsilon I means here only we proved na. Array man, tell me. This is what I am waiting on to ask. So this can be written as 2 into separately epsilon x epsilon xik plus 1. Okay, now again, what is epsilon x? Epsilon x is nothing but this only, right? We are saying this value as a true value, so this is called epsilon x. Why so? Why so means epsilon x is nothing but again probability that capital xi1 plus x2 zar I2 zar and so on, xik equals to 0 minus half. This is what into epsilon xik plus 1. Again, this can be written as epsilon with I1, I2 and so on ik into epsilon xik plus 1. Now this step can be written as 2 into like this, directly substitution. 5 into epsilon ij, j equals to 1 to k into epsilon xij. Okay, whatever, if this normal notations, bacha notations only. So 2 into x naught is not x is there, xik. Okay bro, happy you understand my point? So finally we can club whole this thing as 2 power k like 1 plus 1 into j equals to 1 plus. So finally what we have done, so this whole value is tracking this. So this is saying that is that key, the statement is true for k plus 1 also. Okay, so once hence by induction by proof by induction, I mean regular induction template, we say that hence it is proved. Okay, hence our statement is true for all k greater than or equals to. So this is what piling up lemma and their proof. Okay, next color early. So I will tell it, please write down. So let this epsilon I1 I2 and so on, not I1 I2, this subscript only, okay, denote basis of random variable xi1 dot suppose there is one person who don't work in a group, there is one spoiled person, okay, that person is enough to spoil whole other group, even those are good people. Okay, they slowly, that spoiled person, they slowly inject and spoil others also, other life also. That's why one has to find in their life, if there is spoiled person, we should not shout at him, just we have to identify them and we have to stay avoiding. Means see, like our Reddy sir also will tell that the smartest way to kill others, what is that smartest way? Tell me. The smartest way to kill other is just ignore him. Okay, don't kill. If you kill, then police people will come and will take you to a jail on next day itself. So the next day means you are there, you are going like this. There again, there big person came, hurdle person. One big hurdle came, then you just ignore him and take another part. Just go him. So just block him. Okay, like that. Suppose if epsilon ij equals to 0 for some j, then epsilon I1 I2 and so on ik equals to 0. This is called bachat. You can understand. Okay, that's all about today class. So bye, tata, bye bye. So if anything, if you really like this video, you message to me, or wherever you find video, there type comment Jai Shri Krishna. Bye. Okay, you can leave, just I'm doing some nonsense stuff.